Last class, we started talking about factoring quadratics. That's the process where we take one of these standard form quadratics, x squared plus something x plus something, and we break it down into factored form. So we talked about some tricks to doing that. Basically, we have to figure out this puzzle of what's going to multiply to give us this value and add up to this value. And we were able to find those values, which tells us the solutions or the x-intercepts of the graph. So we're going to look at some slightly harder problems today. And pretty much everything we saw before had something in common, and that was that the number in front of x squared was just 1, right? It was always a single x squared. But standard form says that this a value can be any number, right? As long as it's not 0, this can be anything. So what do we do if a is not 1? Because we're going to have to kind of rethink this process. So today we're going to talk about some sort of more advanced factoring methods. So the first one is just simply the greatest common factor method. So anytime I'm taking a look at a quadratic like this, so I see that a, again, that's the first number, the number in front of the squared variable. I see that a is not 1. So I can't just simply break this down into n times n, because n times n doesn't get me back to 5n squared. But I do notice that although we do have a number here, 5, all the numbers in this equation are multiples of 5. So what I'm going to do is I'm going to kind of take that 5 out of the equation. I'm going to undistribute or divide it out. Cool. So I've got the 5 on the outside of the parentheses here. So what I'm going to have left inside is n squared plus 6n plus 40. I mean 8, sorry. Cool. So you can see how we would get there, right? If we worked backwards, we'd have 5 times n is n, or 5 times n squared is 5n squared, 5 times 6n is 30n, and then 5 times 8 gets us back to 40. So we're doing that distribution process backwards. And once we take out the 5 in the equation, we're left with a quadratic that we should be able to factor. Right? That looks like something we saw last class. So let's break it down. And again, that 5 on the outside, we can kind of just ignore it, stick it out there. And we're going to break this other part down. So I've got n and n, and I've got to figure out what's going to multiply to give me 8, and at the same time add up to 6, right? The same kind of puzzle we've been working with. Multiply to get this number, add up to get that number. It looks like 4 and 2 is going to do the job, because 4 times 2 is 8, and 4 plus 2 is 6. So we successfully have this factored, and now we can go ahead and solve. So before we were saying, all right, the zero product property is this idea that says, all right, we're multiplying some stuff together, and it's coming out to be 0. So one of these pieces have to be 0. Even though we have this extra piece with the 5 out there, it doesn't affect that line of thinking, right? 5 times 0 still comes out to be 0. So we simply solve the two pieces. N plus 4 could be 0. All right, this piece could be 0. That means n could be negative 4 as a solution. The other comes out to be n is negative 2. I'm going to skip over that step there. All right, so there's our solutions, the x-intercepts of the graph. So anytime that a is not 1, so we have a number in front of the squared variable, we should check and see, can we just divide it out really cleanly? Let's take a look at another example. So here I have an 8 in front, so we could say, all right, let's see if we can divide out that 8 as a common factor. And we can, but it's not going to be nice. Right? 11 divided by 8 is 11/8. Then we'll have plus 3/8. And I don't know about you, but I'm not going to try to figure out what multiplies to get 3/8 and also adds up to 11/8. Sounds like a lot of trouble. So instead, we're going to try something else, and that's the slide divide method. So the first time I'm going to walk you through this, I'm going to explain everything, and then I'll walk through another one with you so that you kind of get a feel for how fluid this can be. This is my favorite way to solve these types of problems. It's not the strenuous technical algebra way to do it, and I'll show you that at the end of the video. But it is a good method that works really well, and it's faster than the proper way to do it. Okay, so what I'm going to do is I'm going to take whatever a is, so that's the value in front, in this case 8, and I'm going to slide it to the end. All right, we'll just slide it to the right. So we start by sliding. We get r squared plus 11r plus 24. Okay, so I took 8 and I shoved it into the end here, so I get 8 times 3 is 24. Okay, so we've done something kind of illegal here, but we're not going to worry about that for right now, because this is a trick that's going to work really well for us. So step 1 is to slide A to the end. So slide A into C. That's what we did first. All right, once you do that, then we can take this new equation, which is a new equation. It's not the same equation we had before, which is why this is kind of cheating in a way. But anyway, we can factor this. We've got R here, we've got R here, and we got to figure out what multiplies to give me 24, and at the same time adds up to 11. So thinking through my factors of 24, I can do 8 times 3. Right, and you can think through those factors if that doesn't pop out at you. But if you know your multiplication tables really well, that should start to come pretty naturally. But you can verify 8 times 3 is 24, 8 plus 3 is 11. Okay, so we factored, but this is not our final answer. What we need to do now is the divide part. So this is called slide divide for a reason. Our answers are not going to be -8 and -3. So we need to take whatever we slid at the beginning, and now we need to divide. And I guess we factored before that, but we're just going to call this step 2. Okay, so we are going to divide both of these numbers by whatever we slid at the beginning. In this case, we slid 8 was our A value. Okay, so I got R plus 8 over 8, so that's just 1, right? 8 over 8 is 1. And I've got R plus 3/8. Those are my two solutions, right? If I'm trying to solve this to figure out where does R, or what values of R will solve the equation, where do we hit the x-axis? It'd be at -1 and -3/8. R is -1. We solve this. And R is -3/8 if we solve the second factor. Okay, this is the slide divide method, and it is the quickest way to solve these, but it's, like I've been kind of alluding to, it's a little not right. It's a little unfair, it's a little illegal. And that's because of conventions in algebra that make this not okay. So first of all, when we are doing algebra, we always do this like line by line method where we write something directly under the next or the last step. And when we do that, it implies that what was here is equal to what is here, and then we've just changed the form of it a little bit. And when we do algebra, that's typically pretty true. If we look at something like this, this is equal to this is equal to this. We're just changing the way it looks, just changing the form of it. But that's not true here. We cheated. These two equations are not the same thing. So again, I don't mind it for my class because I think this is a really useful trick that makes this process really easy. However, I want to give you a little disclaimer here. If you are taking like an AP calculus test or SAT math test or something like that, where you're expected to show your steps, this is not a valid way to solve this problem, because this implies that these are the same, and they're not. So, continue to do slide divide, but in a very formal setting, you want to do it as scratch work. Cool, so I'm going to go through another problem, and this time I'm going to do it as scratch work. I'm not going to write that first equation that I write underneath here, because that would imply they're the same thing. So I'm going to do this the legit way. And that's still using slide divide, so still using this trick, but doing it as scratch work. Okay, so I got 2x squared plus 3x minus 5. And again, I'm doing this off to the side for a reason. I'm not even going to write the equals 0 part. Okay, so we can take the 2 and slide it to the end. That's how we start slide divide, slide to the end. So 2 into 5 becomes minus 10. And then we factor. So I'm going to take this quadratic I have, draw my parentheses. I'm going to have x and x here. And then I need factors of 10, oops, aggressive, factors of 10, negative 10, that add up to 3. So it's going to be 5 and 2, and I'm going to need the 2 to be minus. Again, I'm going a little quick here through those processes because we've learned that, and I just want to save some time on the video. But you can verify 5 minus 2 is 3, 5 times negative 2 is negative 10. Okay, so we slid, we factored, now we need to divide. So we slid the 2 earlier, so now we're going to divide the 2 here. Okay, so we get x plus 5 over 2, and we get x minus 2 over 2. X minus 1. And then the proper way to use factored form would be to not ever do a fraction. So we can make this look a little bit better by writing it slightly differently as 2x plus 5. And again, this is just kind of technical. We like to have a certain look to things when we draw it in factored form, and this is what it should look like. So we slide, we factor, we divide, and then if there's anything that doesn't reduce, then we can bottoms up there. Okay, cool. So what I'm going to do is I'm going to go back to the original equation and write that in. 2x plus 5 times x minus 1. All right, so these are the same thing, right? Once I do the dividing process, I do get back to the original equation, right? So we are back to something that's equal, and we can solve the 2 pieces to find our answers. So the factor on the right is pretty easy. If x minus 1 equals 0, that means x is just 1. Okay, so there's our first answer. This one we might have to think about a little harder. 2x plus 5 equals 0. Then we can solve this. 2x is equal to negative 5. Right, we subtract the 5 over. And then we divide by 2 to get x equals negative 5 over 2. 5 there. Negative 5 over 2. Struggling with the mouse. All right. Cool, so that's the slide divide process, which is my favorite way to do this. This is what I'm going to encourage you to do, because it's much faster than the proper way to do this, but I'll show you that too in a minute. All right, so one last thing that you may have noticed as we were going through this is that this isn't a far cry from what we did before when we just kind of figured it out. We said, all right, we have the n times n, we know that part, we just have to figure out the numbers that go with 8 and 6. And we can kind of do that from the start here, right? Although we don't have it very, very simple, where we have x times x, right? It's not that simple. But there's only one way that we can multiply to get 2x squared, pretty much, right? 2x times x. So the last method, or the next thing I'm going to show you here is just using kind of guessing and checking. And that can be really, really useful for a problem like this. So again, we don't have a is equal to 1. We have some other number for a. And it doesn't divide. 43 doesn't divide by 5. So we could do slide divide here. We could do 5 times 56. So it'll be 5 times 50 is 250 plus 30 more is 280. Then I'm going to find factors of 280 that combine to get 43. No thanks. Okay. So what I'm going to do instead is just guess and check, because although it's not super straightforward how I'm going to break this down, I can do some quick guessing. So right away I said I've got to multiply to get 5k squared. So one way to do that would be 5k times k. It's the only real way we can break apart 5 is 5 times 1. So now I'm going to start just trying to check and see what are the different ways I can break down 56, and are any of those going to come out successful? So let's try a couple numbers and see. First thing that comes to mind is 7 times 8. So you might be thinking that, well, 7 plus 8 is not 43, but this isn't 7 plus 8. Keep in mind when we do our distribution property, we do first times outer, inner, times last. So this is 5 times 8, that's 40, plus 7. So 40 plus 7, it's not quite 43, but we're close. Maybe if we switched around to 8 and 7, these are always going to be plus here. Cool, so if we did 5 and 7, we'd have 5 times 7 is 35, and then 8, 35 and 8 do make 43. So guessing and checking is a really valid method as well, especially if you feel really comfortable with the distribution process, right? For me, it's really easy to go from factored form back to standard form by thinking through how this distributes out. And if we have a nice prime number for a like this, and there's really not that many options. So guessing and checking is a great method as well. Of course, we can solve this if we wanted to. K is going to be -7 on this side. And then over here, if 5k plus 8 equals 0, then 5k equals -8, which means k is -8/5. All right. Cool. Let's see what we got left here. Okay, so like I've been saying, the slide divide method is fine. It's a nice trick. It works really well, but technically it's scratch work because it's not legitimate algebra. It's just kind of a trick. Well, there is a legitimate way to solve this, and you might find that it's just as easy as slide divide. I definitely was intimidated by the proper way to do this, which we call the master product. I was intimidated by this at first, but after a little bit of practice, to me, now it's just as easy, if not easier, than slide divide. The other nice thing about master product is it's going to set you up really well when we get to the polynomials unit, and we have to do some factoring by grouping. So this is how the master product works. We think similarly to the way we did slide divide. We think, what would A times C be? 5 times 4 would be 20. So when we say master product, we're referring to A times C. Okay, so the master product here is 20. We're not just thinking about C, we're thinking about C times A. And we're going to approach this the same way we did our problems earlier. Last class, we said, what's going to multiply to get C and add up to B? So though we are still trying to add up to B, add up to -12, instead of just multiplying to get C, we're going to multiply to get the master product, which is A times C. So really similar to what we did before, but instead of just multiplying or just putting C here, we put in C times A, which in this case is 20. Okay, so we're looking for factors of 20 that add up to 12. So we could do 1 times 20, no, 2 times 10. Ooh, that might work. Let's try it out. 2, let me do a different color here. So 2 and 10. So if I did 2 and 10, we would multiply to get 20, but we're not adding up to -12. Looks like they both need to be negative. -2 times -10 is 20. -2 minus 10 is -12. All right, so we did that, but where do these actually go? So when we're doing the master product, things are going to look a little different here. We're not going to touch this first term, and we're not going to touch the last term. But what we're going to do is we're going to take this middle term and split it into 2 pieces. These 2 pieces that we figured out earlier. I'm going to have 5x squared minus 10x minus 2x plus 4. I've rewritten the equation, the same equation. The only thing I did is I took -12x's and I broke it into -10 and -2. But -10 minus 2 more is the same thing as -12. So we haven't changed anything, just the way it looks. Okay, so now comes the tricky bit. We're going to group our 2 pieces together. Okay, this thing here. So we're going to think of this as the first 2 terms grouped together and the second 2 terms grouped together. And then we're going to do a little bit of that distribution method. And again, if this is already looking a little crazy, we've got one big leap to go. That's why we have the slide divide method, because this is a little bit tricky at first. Okay, let's take a look at what I did. I looked at these 2 terms here and I took out 5x. Right, I'm thinking backwards, I'm undistributing. 5x times x is 5x squared. 5x times -2 is -10x. Okay, on the other side, I'm looking at what can I take out here. I'm going to take out a -2. That's going to leave me behind with x minus 2. So between this term and this term, I notice they have a 2 in common, and I'm going to go ahead and take out the negative as well. So I pulled out -2, which leaves behind x and -2. Again, we can check this with distribution. -2 times x is this. -2 times -2 is this. Cool, so why did I do that? Why did I group this stuff together and kind of split it into pieces? And the reason is because I am looking for this. So you have to think about this on a really big scale. I've got A minus B. I've got these two big terms, right? That thing minus that thing. And these two terms have something in common. They both have an x minus 2 as part of their term. So what I can do here is I can actually take x minus 2 out of the equation. I am undistributing an x minus 2, which is going to leave behind 5x minus 2. And you might need to pause here and figure out what the heck just happened, because this is the tricky part in factoring by grouping and using that master product. So I've got two terms, right? Something minus something. And I asked myself, what did they have in common? And I basically divided that out. So it's the same process we used in the last step. I have two terms subtracting, and I say, what do they both divide by? They both divide by 5x. So I take that out and see what's left over. I'm doing the same thing from here to here, but just on a bigger scale. So we're taking out the whole expression, x minus 2. So now you can see what we're left with is factored form. So x is going to be positive 2, and x is going to be, do this one in my head here, 2/5. You can solve that to verify. Great. So this is the proper way to do it. This is sort of the more complete algebraic method. But slide divide is a great trick to get around this because a lot of students struggle with the grouping. So feel free to use slide divide instead of the master product. But I'm going to definitely encourage you to try this method as well on the homework, because this is something that's going to pop up again later in the year, and it'll be nice if you've gotten some practice now. For next class, just looking ahead, what if we have something like this, where we can't factor it at all? Got x and x, and then 5 and 1 looks promising, right? 5 times 1, but they have to be different signs. So that's not going to give you 6, and that's not going to give you 6. This problem is actually unfactorable. So next class, we're going to take a look at what do we do if just doing this algebraically doesn't work out for us. And we're going to have two different methods, the quadratic formula and something called completing the square. So this is for next time. We're going to save it because I've already gone on for 20 minutes here.